Hello guys, today we'll be talking about steel in buildings and infrastructure. My name is Alvaro Guerra and let's get into the presentation. First of all, what is steel? Well, steel is basically a ferrous metal. Ferrous meaning it contains iron, and as mentioned it is an alloy of iron and carbon, and sometimes with other elements like manganese, chromium and nickel. It is hard due to its carbon content and can either come in forms of strong gray or bluish gray alloy, and it is one of the most widely used materials used in construction for either structural or fabricating members, as you can see in the images below. You may be very familiar with them already. Properties of steel. Well, basically steel, its carbon content determines the strength of it, and basically determines its end use. For instance, increase in carbon content increases the shear stress, which is basically the deformation stress, at which point steel can last before deforming, and its hardness. At the same time, decreases ductility, which is the point at which a material can bend to the point it breaks, and toughness. Also, steel can be hardened and tempered, which is a very interesting treatment of steel to give it its necessary properties or required properties such as adequate strength or rigidity. We'll be covering the three different types of steel and their uses. First being mild steel. Mild steel, as the name implies, is also known as low carbon or soft steel. It is ductile, malleable, tougher and more elastic than wrought iron. Mild steel can be forged and welded, so it's a very versatile material. But it is difficult to temper and harden due to its mild carbon content. Therefore, it rusts quickly and can be permanently magnetized. Like all steels, it can rust quickly. And it has a very impressive compressive and tensile strength at 800 to 1200 Newton per millimeter square and 600 to 800 newtons per millimeter square, and has a very impressive specific gravity of 7.30. Mild steel is used in the form of roll sections, reinforcing bars, which is the most common use of steel in construction, ranging into floor slabs and foundations as a means of reinforcement, and roof coverings, which you may all be familiar, and sheet piles, and in railway tracks. And as mentioned before, here are some pictures showing the roof coverings on your left hand side, and on your right hand side showing the reinforcing bars, which I'm pretty sure most of you may already be familiar with. It is the most common use of steel in construction. And on your bottom side there shows sheet piles, which is a method of shoring or a means of barricade, whereby these huge piles are driven into the ground by means of machinery. So these are some areas in which mild steel can be used. High carbon steel. As the name implies, high carbon steel has a high carbon content, and it generally varies from 0.55 to 1.50%. And for that reason, it is also known as hard steel, because as we mentioned earlier, the carbon content increases its strength but also reduces its ductility. For that reason, it is tougher and more elastic than mild steel and can be forged and welded with difficulty. Due to its high carbon content, it is more harder to weld and forge. And it has an ultimate compressive and tensile strength at a whopping 1,350 newtons per millimeter square and 1,400 to 2,000 newton millimeter square, which is very impressive. And it has a specific gravity of 7.90, so it's a very heavy material. Its high carbon steel is used for reinforcing cement concrete and prestressed concrete members. Prestressed concrete members in the form of piles, prestressed piles, and as well as beams where high strength is required. For that reason, it can take shocks and vibrations and is used for making tools and machine parts, tools such as the heads of hammers and so forth, and machine parts which relatively require good strength in order for them to operate. As you can see on your left hand side, this is a picture showing high carbon steel in pre-stressed concrete members, where we may all imagine they require good strength and stability. And on your right hand side is a picture showing a high carbon steel ball peen hammer, and you might imagine why the use of high carbon steel, due to the constant banging of the hammer. So for its use, it is a very appropriate material. High tensile steel. Well, as the name implies, the carbon content is high, and therefore it ranges from 0.6 to 0.8%. And of course other elements such as manganese, silicon, sulfur, and phosphorus. High tensile steel is also known as high strength steel. So you may be hearing these two names constantly, but they are the same. And therefore it is a medium carbon steel due to its high tensile capacity. And its ultimate tensile strength is at a whopping 2,000 Newton per millimeter square. And it has a minimum elongation of 10%, which is very impressive. The high tensile steel is used in pre-stressed concrete construction, where high tensile steel is very much required, and in the buildings of bridges, where you may imagine the wind pressure, therefore the constant tensile stresses that occur there, and makes high tensile steel a very appropriate material in that use. Here are some pictures showing high tensile steel as well as a bridge made of high tensile steel. Steel used in buildings. As you may imagine, any building built in these times, steel is a must. And steel is therefore used in buildings as structural sections, which I will be showing you a picture of their different shapes in just a few. And these provide a strong stiff frame for the building. So basically they make up the frame, such as the beams and the columns, which come in sections, and it makes up 25% of all the steel used in buildings. So this is a very good amount which are used in structural sections. And next, reinforcing bars, which as I mentioned are one of the most common uses of steel in buildings, and they are used to add tensile strength and stiffness to concrete, and they make up 44% of all the steel used in buildings. So as you have seen, this is a very high percentage. Steel therefore is used because it binds well to concrete. Of course, it binds well to concrete due to its deformation. As the name implies, deform bars. and they have a similar thermal expansion coefficient and is strong and relatively cost effective. Sheet products is another use of steel in buildings, and they generally take up 31% of all the materials used in building, of all steel used in buildings. And they come in products such as roofing, purlins, internal walls, ceilings, claddings, insulating panels for exterior walls, where high strength is preferred. As we mentioned earlier, you can see on your right hand side the picture of the structural sections used in buildings for frames requiring high strength. And they come in the shape of T-bars, L-angles, high-strength steel, wide flange, I-beams, and channels, where I-beams are one of the most commonly seen structural cross-sections out there. And on your left-hand side, you can see a picture illustrating how these structural sections are joined to one another. In this case, they are bolted to one another, but they can also be welded to one another. And it is basically showing also, on a side note, one of the main properties of steel whereby it can rust. It's prone to rust, if you may have noticed. Next, uses of steel in infrastructure. Infrastructure being the fundamental facilities and systems serving a country, and therefore they include transport networks, where steel is required for bridges, as we mentioned earlier, tunnels, rail tracks, and in the construction of buildings such as fueling stations, ports, and airports. And these compose about 60% of steel used in this application are rebars, and the rest are sections. So this is a very astonishing amount being used of steel in rebars and in sections. They are also used in utilities, which you may have guessed are fuel, water, and power, whereby 50% of the steel used for this application runs in the underground pipelines, which are used to distribute water to and from your house and to distribute gas. The rest is mainly rebar for power stations and pumping houses. Now we'll be going over the benefits of using steel in construction, and I'm pretty sure you may have been aware of some of these, but some of these are very good to take in account. First one being is steel is reusable and endlessly recyclable. As we mentioned earlier, due to its properties, steel can be melted and reshaped, and for that reason it is reusable and recyclable, so it's very environmentally friendly. Next, number 2, it enables energy efficiency in buildings and construction projects. Due to its properties, as we mentioned, it's a very cost effective material in certain countries, so it enables energy efficiency in buildings and construction projects. Number 3, it's a very strong material, requiring fewer beams and providing more usable open space. So, as we mentioned, the steel is very strong in both tensile or flexural strength, and therefore, as opposed to using another material, in this case we require fewer beams or columns in order to take up that amount of load. So it allows for a more wider usable open space, which is a very great aspect to look into. Number 4, light, requiring reduced foundations. So basically, because of its properties such as strength, it can require smaller foundations to take up the amount of load necessary. Number 5, it is less Less material implies resource saving and a lesser impact on the environment. Number 6, it is flexible in combination with other materials. Yes, steel has a very good flexural strength and ductility as compared to other materials, which your point of breaking is very high. Earthquake resistant due to steel's ductility. This is structural properties. It is a very good material to resist tensile movement or shear stress. It is fast on site build for prefabricated buildings, and this is a property or a benefit that is very noticeable in modern construction, because many of the buildings now are built on site. They are prefabricated members of steel that are joined on site, and therefore they provide fast on site assembly. Number 9, they are durable. Just the properties itself give that one away because of its properties, the carbon content, and they are made of iron, which is already a durable material. Here we'll be showing you some pictures of different buildings in the world that you may have heard of that are made of steel. One being the Eiffel Tower and the Burj Khalifa, also the Sears Towers. Next, the National Olympic Stadium in China and the Golden Gate. The Disney Concert Hall in Los Angeles and the Montreal Biosphere. So as you may have seen, apart from very good properties, tensile as well as compressive strength, they have very good appearance. They give a very nice aesthetic appearance to the buildings. And here we'll be showing you a very nice video, basically summing up the entirety of the presentation.
Steel is a magical mixture of amazing ingredients, mainly iron, the Earth's fourth most common element, and carbon. Depending on what is added, steel can be soft and malleable, or hard and brittle. It can also be rolled, forged, heated, and cooled. You can basically make whatever you want. It all depends on the final destination. Steel can become a bridge, a railway, or a skyscraper, wind turbine, jewelry, or dishwasher, computer, football stadium, watch, knife, chair, bench, table, bed, saw, drill, pot, cylinder block, roof, or ventilation unit. All manner of things. If you manage to find something without steel in it, then it's surely been produced by a tool or mold made of steel. So, why are we telling you this? Well, the fact is that we in the steel industry have a problem. A recent survey showed that when people hear steel industry, they think dirt, smoke, fire, and yuck. That's wrong, we say, impartial as we are. New and better ways of making modern steel are invented every year. Many people think that a job in the steel industry looks like this, when in reality, it looks like this. Each day, we create enough steel to build 548 Eiffel Towers. That's more than 2 per country in the world. In 2012, the steel industry had a turnover of more than $800 billion, yielding over $100 billion in tax. This equates to putting 10 million students through school each year, or building more than 5,000 new hospitals. And about 8 million people, equivalent to the population of Switzerland, work in our industry. Another really good thing about steel is that it is recycled time and again, but loses 0% in quality. The steel in your washing machine yesterday can be a surgical scalpel or a mobile phone tomorrow. All the time, new types of steel are being developed. Stronger, more flexible, and cleaner. The effect? Well, one example, our new lightweight steel is used in modern cars to make them lighter. Lighter cars use less fuel, and less fuel makes our world a little better. So, there you have it. Condensed and useful information about steel. Would you like to be a part of our efforts to shape the world we share, to make it a little better, lighter, more flexible, and brighter? Start by visiting worldsteel.org.
Okay, guys, thank you so much for your attention. And this was the end of my presentation.